Hello friends, this is Computer Networks lecture number 2. The topic is framing. As we know, if we send the data packets on channel in continuous manner, then the problems occur how the receivers identify from where to where there is a packet 1 and from where to where the packet number 2. So to identify the boundaries of the packets or frames, we will come to identify the boundaries of the packets, we will introduce framing. Here the receivers and the transmitter, here the frame 1, frame 2, frame 3, they have they are in continuous manner, but there is a boundary between frames. The solution is there are three methods to define the boundaries of the frames. The first one is byte count, and the second one is byte stuffing, and third is bit stuffing. Byte count and byte stuffing is not too important in gate perspectives. The third one, bit stuffing, is important, but we will learn byte count and byte stuffing also. Okay. First one is byte count field. In byte count field, actually we add one extra byte in the beginning of the frame. In the first byte of the frame, we contain the size of the frame. Next example, here there is a continuous manner. There is a multiple frames. In multiple frames, the first byte of the frame contain the size of frame size. Here there is a multiple frames. Here the first byte of the frame contain the size of that frame. Here the frame size is 5, means from here to up to 5 byte there is a frame number 1. So there is frame 1, 2, 3, 4, 5. From here to here there is a frame number 1. Then there is a size of another frame size 3. From here 1, 2, 3. This from 3 to 26 there is a frame number 2. From this manner the receiver can identify the frame boundaries. If we found any error between frame data, if we found any error from 25 to 200, means this data in payload data of the frame, then the transmitter again send the data to the receiver. But the problem arises when there is a count. Frame size byte might be changed due to noise channel. Means from here there is 5, means there is a 5 bytes is the size of the frame. But if it change by noise channel, means in transmission, if there is any error because of that, if the size of frame change, then let example, if it will become 6, then from here to 6 up to 3 there is a frame 1, and from 45 from here the frame 2 will be started. So the size of frame 2 will be 45, and it will cause and because of that, because there is frame 2 start from here and up to there is a 45 byte. So we see that there is a problem because our frame is start from 3 to 26, but due to the error byte size, there is a error occurred in all frame boundaries. All frames boundary will be changed. So there is a error. So that is a drawback of this type byte, this byte count method. Okay. The disadvantage is that if there are occurred, then byte count field, then entire transmission is disturbed. Okay. Now the byte stuffing. In byte stuffing, we use special characters. Stuffing in starting of the flag, in starting of the packet, we will uh, add a starting delimiter and ending delimiter. Here the STX is a starting frame delimiter and the ETX is a end frame delimiter. Means that we are these skies values are 2 and 3, and the escape character whose sky value 27. Let's understand how it will happen. Here is the frame, and there is a header and footer. These all collectively called frame. Okay. If we then send the frame to a channel, we add STX and ETX. STX is as a starting delimiter and ETX is as a ending delimiter. Means how the receiver will when receiver receive STX, then it will start identify that this is a starting. From here the frame is being started, and when receiver get ETX, then receiver will identify as this is a ending. From here the frame is end. From here to here there is a one single frame. One single frame. So the disadvantage means the problem occurs in this method. Means if the frame already in frame there is a data, user data or message which we want to send, but if there is a STX already present in data or ETX present in data, means this, let's example, if STX is a starting delimiter or in frame data there is already ETX is present, then what happens at that time? If in data there is a ETX present, the ending delimiter is present, then before that we stuff escape character before the ETX which is in data, present in frame data. So when the receiver receives STX, okay, it is count starting frame, the identify here. From here the frame is starting, and then come forward, and he found escape character and then ETX. Before ETX they found escape character, so it identify this is not a ending delimiter, it is a part of data of a frame. So it will discard the escape character and take ETX as a data of the frame and go forward and found again ETX. But before it is it not found escape character, so it will identify yes this is a ending delimiter, and from here the frame 1 is end. From here from next there is a STX delimiter which will identify here the from here second frame is started. Okay. Then the disadvantage of this method is if there is a multiple ETX or STX in containing payload, then for each STX or each ETX we should have to stuff escape character. So the size of the frame is increase more. The size of escape character will increase more. So the efficiency of the channel will decrease. So another method comes for the solution, bit stuffing. The bit stuffing is a little bit similar to the byte stuffing. Here in place of STX or ETX we use flag character, where here our flag is default flag is this symbol. Here their sky value is 126 and their binary value is this. 0 and triple ones and 0. Okay, standard. Here the same, the frames is the header, payload and footer. Frame contain header, payload and footer. Before the frame we add flag character, which is okay, which is 0 1 1 1 1 0 0 flag, then frame, then again flag. Here the details how it work, I will explain it. Next, this is our data which we want to send. Okay, which want to send means there is a frame. We know that in byte stuffing we add flags before and after the frame, so the receiver can identify the starting and ending of the frame. So we use flag. What is our flag? 0 triple 1 and 0, and the ending flag is 0 triple 1 and 0. Okay, I will put it before and end of our data. But what happened if data already contain, if the data already contain 0 triple 6, sorry, 0 6 times 1 and 0. So if there is a starting flag, receiver see there is a okay starting flag, then here receivers again found same 0 6 3 times 6 times 1 and 0, means here the receiver identify this as a ending flag, but this is a part of our data, so part of data, so the receiver take it as a ending flag and start another count another frame from here, but this is a problem, it will be wrong now. So to solve this problem we add 1, so we add 0 after every 5 ones. Okay, again we add stuff means add we stuff 0 after every once if the data contain more than 1 6 in continuous manner. If our data contain more than 5 ones in continuous manner, then after 5 continuous ones we stuff 0, so that the receiver can identify this is not the ending delimiter, this is a part of data. Okay, let's example. Here the starting flag, then 1 0 1 2 3 4 5, after 5 we stuff 0, and then again our data in our data there is a 6 7 7 ones, 5 once I have completed, then we stuff 0 because after 5 we have to stuff 0, then 1 1, then 0 1 0 1. This is the data. After data completed, then we stuff ending flag 0 1 1 1 1 1 1 0. This is an ending flag. Receiver will identify this is a ending flag, so receiver ignore starting flag and ending flag and take from here to here as a data and forward it to higher layer. Then again how receiver will identify? Receiver will identify this is a starting flag, then receiver will ignore it, and from here receiver will store this in a buffer like 1 0 1 1 1 1 1 5. After 5 ones receiver found 0, receiver will know after every 5 ones there is a 0 stuffing, so receiver will ignore this, receiver will ignore this, will discard this, and again start from here 1 0 0 0 1, and from here to here it will ignore because this is a ending flag, this is a Indian flag because there are just 6 ones and there is 0 and 0 in starting end. This is our flag. So this bit stuffing is completed. Advantage is of the bit stuffing is that here we stuff 0 means single bit. If there is a continuous means if the data contains delimiters or flags, we stuff a single bit of the single bit to identify the flags. But in byte stuffing we add escape character. I use escape characters. If the data contains a starting or ending delimiters, before that we use escape character. Escape character had taken more byte than 0 bit. Escape character contain byte, take byte of space, but here there is a width which we take only 1 bit of space. So the size will not cite the size of frame. Size of frame will not increase too much. So this is a very good method. So this method is a very efficient method for the framing. So the byte here we have learned 3 types of methods: byte count, byte stuffing, and bit stuffing.